Hello and welcome. In this video, we are going to get introduced to Open Closed Principle or OCP. So this is what OCP says. It says that a class should be open for extension and closed for modification. Note that this principle is a combination of both of these statements. So first of all, let's just understand what these individual statements stand on themselves, and then we'll understand that what both of these statements together mean. So what does open for extension means? When we say that a class is open for extension, it means that a class does not actually stick to a specific functionality. It is written or coded in a generic way so that it is open for extension. Now, open for extension doesn't mean that somebody would be able to extend this class using extends keyword. No, this is really confusing where people take it or misunderstand it. So open for extension means that a class is capable enough to provide more functionality around the same area whenever more requirements come in the future. So this is all about open for extension. Now, when we say that a class is closed for modification, it means that we shouldn't be required to modify or change a class. That is, there is no need to modify. There shouldn't be any need to modify a class. Now, these were the individual explanation of these individual statements. Now, when OCP says that it's a combination of both of these statements, then it means that a class should be able to provide more functionality rather than sticking to a single functionality. It should be written in that much generic way that tomorrow, if there are more requirements around the same area, then it should be able to provide more functionality without modifying its source code. Now, the question that you might be getting at this point is that how is it possible for a class to be written in such a way that it provides more functionality tomorrow without modifying it, right? So the answer to that is that we should be able to write more code in order to provide more functionality, and that more code will work seamlessly with the already existing code or with the already existing classes so that the new functionality is addressed. In other words, if there are these requirements and we are writing a code, then ideally we should be actually writing the code plus its JUnit. Now, the purpose of the JUnit is to test the code that we have written, and we should be writing this code in such a way that it should be generic enough that tomorrow, if there are more requirements, then we shouldn't be touching this already existing code, but we should be writing more code plus more JUnit, and together this more code with already existing code should work seamlessly so that we get these more requirements also addressed with this code. So this is what OCP means, and if we follow the OCP, then this is how things will be and this is how it should be, because whenever we are writing a code, we shouldn't be going to that code to change that code whenever more requirements come in. We should actually ideally be writing more code for the more requirements, because if we always go and change the already existing code for the more requirements, then the code will become really unstable, and we'll also need to modify the already existing JUnit, which is again a pain. And if we are following OCP, then we'll follow this approach and we will never be required to change an old code which already exists and its testing has been done through JUnits. Now I would like to take a real world example of OCP. We'll take coding examples down the line and we'll understand how we can apply OCP over there. But before that, I wanted to take one real-time example. So I'll take the example of Eclipse. We have seen that we use Eclipse IDE in our day-to-day development, and we can install various plugins in Eclipse. So let's say that there is a plugin which is SmartSave, and if you install that plugin into your Eclipse, then Eclipse provide added capability to save the files after editing has been done on regular intervals. So after the plugin is installed in the Eclipse, Eclipse actually start providing added capability. Now, in this overall flow, if you observe, Eclipse was a program which was actually running on your computer, and then a plugin came with more code, and it did not actually modify the already existing code of the Eclipse. It came with a more code, and this additional code worked very well. It gelled very well with the existing code of the Eclipse, and as a result, it started providing the added capability. This is a wonderful example of OCP, where we see that there's already existing some code and it's running fine, and we get this additional code, and when we combine both of this code, then Eclipse start to provide added capability, right? So in this case, Eclipse is actually following OCP, and we can say that it is open for extension and closed for modification at the same time, because it allowed its functionality to be extended without modifying its source code. Thank you very much.